All right, Honors Algebra, you should be looking at your 8.3 notes. This is day 2. We're going to start with example D. If you look here, we do have an equation in quadratic form. Now, the reason it's in quadratic form is because of the special pattern that we see. Our highest degree is to the negative second, and then our next degree is to the negative first, and then our constant is to the 0 degree. This is actually twice the middle term. So it's still in a quadratic form, it just looks quite peculiar, that's all. So we can use substitution. We're going to let u equal our middle term here, which is x to the negative first power. I know that doesn't really make sense right now, but that means this is going to turn into a u. And that means if I went ahead and squared that, if I went ahead and squared each term, actually I just did that, sorry. If I went ahead and squared that, I'm going to get u squared equals x to the negative second, which is exactly what I have here. So this ends up being u squared. So we can rewrite this as 4u squared plus 4u minus 15 equals 0. So from this point on, if you go ahead and try to factor that trinomial, looking for a product that gives us negative 15 when multiplied and adds to positive 4, we're not going to find type 1 or type 2. So what we're going to have to do right now is we're going to go ahead and use the quadratic formula, identifying our a, b, and c terms. So our a term is going to be 4. Our b is going to be 4, and our c is going to be negative 15. So right now what we're going to do is we're going to solve for u, and using the quadratic formula, opposite of b. So we're going to use the opposite of 4, plus and minus the square root of b squared minus 4 times a times c, all over 2 times a. So if we go ahead and substitute in, b here is 4, a is 4, and c is negative 15, all over 2 times 4. So if we go ahead and solve that, we're going to go ahead and get negative 4 plus and minus. We have 4 squared, which is 16. If I scope this out, I'm going to have 2 negatives, which ends up being 16 times 15, which is a positive 240, all over 8. So if we simplify this even more, we're going to get the square root of 256 all over 8. And this is a plus and minus here. If we carry forward, we're going to get negative 4 plus and minus. The square root of 256 is 16 all over 8. Now we're not done because we actually have 2 real nice answers here. And we have, if we separate them out, we have negative 4 plus 16 over 8, which is 12/8, which reduces to 3/2. And each of them are divisible by 2. Or I should say each of them are divisible by 4. And so divisible by 4, I'm going to get 3/2. And here I'm going to get negative 4 minus 16 over 8, which is negative 28. And each of them are divisible by 4 again, which is negative 5/2. Now, there are 2 answers for u, but remember, in our original problem, we want to solve for x. So what we're going to do is substitute in, these are our answers for u, so u equals 3/2, and we got u equals negative 5/2. But we have to go back and substitute in what u was equal to. So u is equal to x to the negative first. Sorry about that thickness there. And also x to the negative first was equal to negative 5/2. Now we're not done because we really can't leave a negative exponent like this. This is improper. So we can rewrite x to the negative first with a positive exponent by writing 1 over positive x, which is equal to, basically we're just taking the reciprocal. So the reciprocal of 3/2, if we flip that whole fraction, is 2/3. Sorry, let me redo that. 1 over x is equal to 3/2, but we want to solve for x. So to solve for x, if we just take the reciprocal of x, we're going to take the reciprocal of 3/2, which is 2/3. So x is equal to 2/3. And the same here, x to the negative first is really 1 over x divided by x, which is equal to negative 5/2. But again, since we want to solve for x, we want to multiply by the reciprocal, which is just x over 1, or x. So we're also just going to take the reciprocal of negative 5/2, which is equal to negative 2/5. So here we finally solved for x. Sorry, that's 2/3. Okay. So there are our two answers. And that's how you do part D. Okay? Now let's take a look at E. This even looks more so, it looks very confusing, but it actually, believe it or not, is in quadratic form because it too has a pattern. So if you're like, well, how does this have a pattern? Isn't our first degree supposed to be twice that of our middle term? And it actually is. So if we let u equal z to the 1/3 power, remember, if we multiply this by 2, just remember we did part C already in today's notes, so we're just doing D and E. So if we multiply this by 2, we're really raising it if we go ahead and raise this to the second power, right? We're raising this to the second power. That means we're really going to get z to the 2/3, which is equal to u squared. And lo and behold, we have z to the 2/3, so this is our u squared term. So remember, when you have a power raised to a power, you multiply the exponents. That's how we get 2/3. So this is really u squared minus u, since u is z to the 1/3, minus 6 equals 0. And what works out nice about this is a type 1 type factor. So we're looking for a product of -6, but adds to a -1. So if you go ahead right now and look for factors, we're going to get u times u, and then 3 and 2. Be careful of the signs. The higher number has to have the negative sign, and we're going to get u minus 3 and u plus 2 equals 0. So if I go ahead and rewrite these and set each term equal to 0 and solve, I'm going to get u equals 3, and here I'm going to get u equals -2. Now remember, this is all nice, but we're really not done, because in our original problem we're actually solving for z. So we have to go back and substitute in what u equaled. And u equaled z to the 1/3 power. So we're going to simply replace our u back with our z to the 1/3. So z to the 1/3 power equals 3, and z to the 1/3 power here equals -2. Okay, we're almost done, not quite. Our goal is to solve for z, and right now I have it raised to the 1/3 power. So I'm going to have to do something mathematically to make this just z to the first power. So kind of giving you an idea of something we did up here, can you take a guess what we're going to have to do with that z to the 1/3 power? So maybe you want to take a moment to pause and see what you need to do. So right now we're ready to go ahead and solve this. To get z to the 1/3 power, I want to make that z to the first power. If I multiply anything by its reciprocal, I'm going to get 1. So that means if I take z to the 1/3 and multiply it and raise it to that third power. And again, if I'm going to do that on the left side here, I'm going to have to do that here. And I'll raise it to the third, and that means I'm raising this to the third power. So z to 1/3 to the third power is really z to the first, because this is z to the 3/3 power, which is just z, and that's what we're looking for. So 3 cubed, remember, is 27. And here again, I have z to the 3/3, which is really z. And negative 2 to the third power is negative 8. So here are our two solutions. And we are done with part E. So if we go ahead and turn to the back side, on problem 2, it's saying suppose that f of x equals x to the 4th minus 6x squared minus 27. And they want us to find the values of x such that f of x equals negative 35. So we are looking for our inputs for x such that our y value, or f of x, equals negative 35. Please do not substitute negative 35 in place of x. That would just be wrong. We're actually going to take negative 35 and replace it for all of f of x. So what we're doing